This is the last lesson for graphing trig functions. We're going to be graphing cosecant and secant today. So the first thing that we want to talk about when we look at cosecant is remember what sine is. Remember that sine and cosecant go together because cosecant is the reciprocal of sine. So if you remember sine, at 0, sine was at 0, right? At pi over 2, we were at 1. At pi, we were at 0. At 3 pi over 2, we were at -1. And at 2 pi, we were back at 0. So if you remember sine, okay, this is what it looked like. And this pattern would continue. So I'm just going to continue it for us so we can see it. Okay. What we need to remember, though, is since they're reciprocals, okay, what is the reciprocal of sine when we're at 0? Okay, so we are going to have a lot more values for cosecant than what we do for sine, because we need to really see what's happening. So if we look at just 0, what's the reciprocal of 0? It is undefined, right? And this means then that there is an asymptote here because it's undefined. Where else do we hit 0? Well, we hit it right here, which is pi. So at pi, that means we have another asymptote here. Okay? We hit 0 again at 2 pi. Okay, so here at 2 pi is also undefined. I'm going to erase this part just so it doesn't confuse you. So that means we do have another asymptote here at 2 pi. Then we look and see what the reciprocal is of 1, right? So at pi over 2, so I have pi over 2 here, and the reciprocal of 1 is 1. And then at 3 pi over 2, that's my other point here, its reciprocal of -1 is -1. So now you're going to notice that I have some spots that are empty here, right? Because seeing asymptotes and then just a point isn't going to give me a full graph, okay? So we have to find out what's happening in between them. So now I'm going to start talking about some of the changes that are a little bit different in cosecant. So for cosecant, we go back to having a period of 2 pi because it is the reciprocal of sine. Now, instead of our interval being our period divided by 4, our period is going to be divided by 8. So our period now is 2 pi over 8, which if we simplify is pi over 4. Sorry, the period is 2 pi over 8. This is finding the interval, okay? So don't mean to confuse you here. So it's the period over 8, which is 2 pi over 8. So that's pi over 4. So that's how we're going to find our x values, okay? So when I start at 0, okay, because that's where I'm undefined, I'm going to add pi over 4. I'm going to add pi over 4. That gives me 2 pi over 4, or pi over 2. Add pi over 4 again. That's 3 pi over 4. And pi over 4 again. That's 4 pi over 4, or pi. Add it again. It's going to give me 5 pi over 4. Add it again. That's 6 pi over 4, which reduces to 3 pi over 2. Add it again. We're going to have 7 pi over 4. Add it again. Gives me 8 pi over 4, which is 2 pi. So I get the rest of these values here just by the interval. If you wanted to start at 0 and just add, that's fine too. But just to introduce it, I wanted you to see how we're getting these cosecant values. It's because it's the reciprocal of sine. Okay, so now I need to see what's happening here for these y values. Okay, so for these y values, again, just refer back to the unit circle. So cosecant of pi over 4 is the square root of 2. Cosecant of 3 pi over 4 is the square root of 2. Cosecant of 5 pi over 4 is negative square root of 2. And cosecant of 7 pi over 4 is negative square root of 2. So now that we have all these other values, we can go ahead and continue this graph. So at pi over 4, we're at the square root of 2, which if you get an exact value, it's about 1.4. So we're going to have this 1, and then here we're at about 1.4. So we know about asymptotes is we can't cross them. So they're going to come super close and have a nice smooth curve. Okay. When I go to the second part, I have 5 pi over 4. We're down at negative, right? So we're about down here at the negative 1/2, about. We're negative 1, back here. So we're going to get, again, close to the asymptote, but we're not going to cross it. Okay, so this sign kind of helps us see why cosecant looks like it does. Okay, I kind of wanted to erase the red there, but I don't think it's going to work. Maybe I'll try to just white it out. Because I want you to be able to see what cosecant looks like independent of sine, because you're not going to be graphing sine every time you graph cosecant. That was just to kind of show you how we're getting our values and kind of where we're starting from. Okay, so that is what the graph of cosecant looks like as the parent function. If you notice, you kind of have some chunks, right? So this chunk, we're going to call an up chunk, and this one we're going to call a down chunk, okay? So when you're doing cosecant, from 0 to 2 pi is one full period. So you have to have an up chunk as well as a down chunk in one entire period. And then this pattern is just going to continue. So at every whole interval of pi, there's going to be another asymptote, and then this pattern is just going to continue on and on and on and on. There is a formula for the asymptotes. So typically, in order to get them, there are two formulas. The first one is just c divided by b. So in this case, we don't have a c, that's 0. B is 1, so one asymptote is at 0, which we know. And then our next one is c plus pi divided by b. C is 0 plus pi is going to be pi over 1, so we have another asymptote at pi, which we know. The asymptotes then are going to be at every whole interval of pi. So we'll have one at 0, pi, 2 pi, 3 pi, 4 pi, and so on. Okay? So take a minute, kind of digest this a little bit, see if we have any questions. But the most important part is just being able to see why cosecant looks like it does, and it looks like it does because it's the inverse of sine. Okay? So we have cosecant times 2. So what is this 2 going to do to the graph? Okay? What is it going to happen here? So this 2 is going to change. What we were talking about was the amplitude. However, cosecant doesn't have an amplitude. If you look back at that graph, there is no height because it continues on. So this 2, we're just going to multiply by our y values. Okay? So if you want to start from the beginning, typically on a problem I would start by finding my asymptotes. So you're going to do c divided by b. So here it's 0 over 1. So I have one at 0. So plot that asymptote first. Then we have c plus pi over b, which is pi over 1, which is, sorry, not 0, pi. So I have another one at pi. So that means I'm going to have another one at every interval of pi. So I also know I have one at 2 pi. Okay, let's go ahead and start to build our x table. So since my asymptote is 0, that's where I'm going to start, just because I know that that is going to be an undefined value. I also know I have an asymptote at pi. That's going to be an undefined value. And then I know I have one at 2 pi, and that is also going to be an undefined value. So now we need to look at the values for our up chunk and our down chunk. In each chunk, there should be 3 key points. So you should have 3 points you're going to plot in between each set of asymptotes. Okay? So the next thing you want to do is find your interval. So you take your period, which is 2 pi, and you divide it by 8. Okay? Remember, with cosecant, we divide by 8 instead of 4. So it also simplifies to the pi over 4 if you'd like to do that. So start at 0, add pi over 4, add pi over 4, add pi over 4, add pi over 4, that takes you to 4 pi over 4, which is just pi, 5 pi over 4, 6 pi over 4, 7 pi over 4, and then that takes you to your 8 pi. If you want to simplify these, you know this is 3 pi over 2. If you want to simplify this one, it's just pi over 2. Think about our unit circle. So cosecant of pi over 4 is the square root of 2, but I'm multiplying that by 2. So 2 times the square root of 2, which the square root of 2 is about 1.4, so multiply by 2, so we get about 2.8. What you're going to be able to see here then is a pattern. So the first and third value are always going to be the same, because they're both timesing by the square root of 2. And then the one in the middle is going to be multiplied by 1. So 2 times 1, so that's just 2. So let's plot that first. So at pi over 4, we're at about 2.8. Here at about 2.8. So here's my up portion. Okay. And then I have this down chunk. So this down chunk, we want to, if you notice from the last one, it's going to be the exact same values from the up portion. They're just going to be negative because I have no vertical shift. So these should be equidistant from each other. So this is just going to be negative 2 times the square root of 2, negative 1 times 2, and negative 2 times the square root of 2. So that gives us the negative 2.8, a negative 2, and the negative 2.8. So let's go and plot those points. So we're going to plot these. Again, it's nice to be able to think about here, you know, if this 2 was an amplitude for sine, sine would have been up at 2. So you can still kind of picture the curve of sine in here and how it's helping us form cosecant. Okay? What is this pi over 3? Or theta over 3? What is that going to do to our graph? Okay, pi over 3, that is going to change our period. Okay, so since we know that, let's look at the period first this time. The period is 2 pi divided by 1/3, multiplied by the reciprocal, so you're going to have 6 pi. Let's go ahead and then find the asymptotes, because we like to find those first. So we have 0 over 1/3, which is 0. So I'm going to plot that one first. Okay. You can also make your table at the same time if you want. Sometimes that's helpful. Then we have pi divided by 1/3, which is going to give us 3 pi. So I know another asymptote is going to be at 3 pi. And then, so if you look at this section, so 0 to 3 pi, you're going to add 3 pi again to get the next asymptote. So 3 pi plus 3 pi is 6 pi. And that is also undefined. So I know I have another one over here. Okay. In order to fill in the pieces, we need to find our interval. Okay, so your interval is your period, which is 6 pi, and we divide by 8. If you want to leave in terms of eighths, that's fine. If you want to simplify to terms of fourths, that's fine. Either way doesn't matter. I'm going to do eighths just because they're already there. So we have 6 pi over 8, and we're going to have 12 pi over 8, then we're going to have 18 pi over 8. 18 plus 6 would be 24, which 24 divided by 8 gives us the 3. We'd have 30 pi over 8, and then 36 pi over 8, and then 42 pi over 8. If we add again, that gives us the 6 pi. Okay. There is no change in your y values at all when you're changing just the period. So if you can remember the pattern, it's the square root of 2, 1, square root of 2, and then negative square root of 2, negative 1, negative square root of 2. Okay. We want to start plotting these points. So 6 pi over 8. So we can't really see that on our graph, and our graph doesn't give us enough space to actually plot these individually by eighths. So what we can do is just kind of estimate by seeing what 6/8 is as a fraction. 6/8 would be about 3/4. So that's going to be 3/4 of pi. So we're going to just kind of estimate here, just to the left of pi. 12 over 8 would be 1.5. So I'm going to go to 1.5. Just go here at the 1. 18/8 would be about 2.25. So that is here, the square root of 2. So sometimes you might just have to estimate in between things, and that's okay. We have our asymptote at 3 pi. 30 over 8 is about 3.75. So we're going to go down to the negative 1.4. We're going to go to 4.5 or 36 over 8 and go to the negative 1. And then 5.25 is the 42 over 8, so that's the negative 1.4. And we want to have nice, neat curves. Okay, that is one cycle. If you would like to try this one on your own, go ahead. If not, we're going to do it in class together, okay? So the other one we also want to look at today is secant. So for secant, what we want to do is think about secant in terms of cosine. Why do we get the values that we do for secant? It's because of the inverse values for cosine. Okay. Secant also has a period of 2 pi. Here there's no period change, so my period is 2 pi. And then the asymptote formulas are different. So if you look at the formula sheet that I gave you, to find the asymptotes, it's 6 plus pi over 2 divided by b, and 6 minus pi over 2 divided by b. So here in this case, it's 0 plus pi over 2 divided by 1, which is just going to be pi over 2. And c minus pi over 2 is going to give us negative pi over 2. Okay, so at pi over 2, we're going to have an asymptote. And we also have one at negative pi over 2. Now, I know our graph doesn't look very good here, and we don't have quite enough spaces for everything. This is kind of where it would be if we estimate. Okay. That means at all values of pi over 2, all multiples of them, there's going to be an asymptote. So I'm also going to have one at 3 pi over 2. I would have one at 5 pi over 2. I would have another one, and they would keep continuing on and on and on. Okay? But these are the three main ones that we want in order to do our graph. So we're going to start at negative pi over 2. Since the period is 2 pi, we're going to divide by 8 with our interval. So we're going to have pi over 4. If I add pi over 4, I'm going to get a negative pi over 4. Add it again, I get 0. Add it again, I get pi over 4. Add it again, I get pi over 2. And at pi over 2, we said we have an asymptote. Keep adding. So we're going to have a 3 pi over 4, 5 pi over 4, and then 3 pi over 2 is also undefined. Whoops, sorry, I missed one. Let's see. In between this 3 pi, I'm actually just going to fill it in here. In between this 3 pi and 5 pi, there should be just a pi. Okay, so right here, I'm going to squeeze it in right here. Okay? The nice thing about secant is it has actually the same pattern as cosecant for the y values. They are at different places on the unit circle, but it ends up working out to be square root of 2, 1 square root of 2, and then negative square root of 2, negative 1, negative square root of 2. That's really nice that happens. It makes us be able to remember them a little bit easier. Okay, let's go ahead and plot these points. Negative pi over 4 is going to be at 1.4. 0 is at 1. Pi over 4 is at the 1.4. Draw our lines, get closer to your asymptote. Here we're going to have the negative 1.4, the negative 1, negative 1.4, and then we have secant. So really, it looks very similar to cosecant. It's just shifted over. Okay? I actually want to save this one for class. So try this one on your own right now. Do it by yourself, and then we're going to start with this one in class. Okay? Let me know if you have any questions. We kind of have seen the basics. We're going to do a lot of practice in class.